So welcome everybody to the Spring 2021 Faculty Forum. A few housekeeping reminders. This presentation is being recorded so that we can share it with more folks around campus. And also during the presentation, if you can make sure that your microphone is muted, that would really minimize extraneous noises and disruptions to the presenter. And in terms of questions, we obviously welcome questions at the end of the presentation. Um, if you can unmute yourself, you can certainly ask questions once the presentation has finished, or if it is your preference, you can drop your question at the chat box. I will be monitoring that, and if necessary, we'll be forwarding your question to the presenter. So today we are very happy and very honored to have Dr. Matthew Haffner here with us. Matt is an assistant professor in the Department of Geography and Anthropology and completed his PhD at Oklahoma State University in 2018. His research interests include spatial data science, urban geography, and spatial cognition. So thank you very much, Matt, for joining us, and the platform is yours.
Okay, great. Thank you, Catherine, and thank you all for being here. I'm excited to give this talk. You may have seen a different title advertised. I have a really bad habit of changing the title of my talk at the very last minute. Can everybody see the screen and hear me okay?
Yes.
Okay, great. Awesome. So I'll get started here. I call this talk replicable and extensible spatial data acquisition. And so I'm going to first talk about the reproducibility crisis in science. So there was a recent study that was conducted by Nature that said more than 70% of researchers have tried and failed to reproduce another scientist's experiments, and more than half have failed to reproduce their own experiment. And if one of the cornerstones of scientific research is reproducibility, being able to test an experiment again and be sure that it worked, this is pretty concerning. And so a number of people within the scientific community view this as a problem. 52% say that this is a significant crisis, and 38% say it's at least a slight crisis. So this is a potentially big problem. And it's not just one or two disciplines that have this sort of issue. This is something that's consistent across the various sciences: chemistry, biology, physics, medicine. So a lot of people perceive this to be a problem, the inability to reproduce an experiment. And there's a question about whether or not such research can be trusted. Can we trust results that are irreproducible? And I think there's some reasonable debate here about whether or not these can be trusted. But certainly in certain circumstances, there are some results that cannot be trusted. And so as part of this study that was conducted in Nature, scientists were asked what factors contribute to irreproducible research, and the top reason is selective reporting, which is highly problematic if researchers are only reporting the results that confirm their hypotheses. Some of these are not quite as extreme, but we see others such as fraud or simply bad luck, which is concerning for the community of the academy. And so I'll now talk about some specific sort of travesties and blunders on the reproducibility front. There was a book published in 2013 by the economist Thomas Piketty called Capital in the 21st Century, and this has been equated to, it's been called our generation's Das Kapital in terms of its scope. And he's talking about the devastating effects of wealth inequality in this book. It's like 700 pages long. And he posted his analysis, his Excel spreadsheets online so people could see what he did. And a number of people have picked up his calculations and found that he made some errors that really weakened some of his arguments. And on the other side of the ideological spectrum, there was a paper published in 2010 called Growth in a Time of Debt. Two other economists posited the question, can a country's economy grow while it's in debt? And basically their conclusion was no. And as a result of this paper, government officials all over the world used this analysis to justify austerity policies. So hike up taxes and cut social programs. Where there was some grad student in Massachusetts somewhere who tried to reproduce the results and was not able to get the same results. And this grad student eventually reached out to The Economist, and they shared their Excel file. And she found that 29 countries have been omitted from the calculation, that when those countries were thrown back into the model, it totally reversed the conclusion of the paper. And this is not just something that is problematic inside of the academy. In the private sector, there are reproducibility issues too. A notable one being JP Morgan, that lost several $billion as a result of making errors in spreadsheets and sort of a cumbersome workflow of copying and pasting from one spreadsheet to another. And it might seem like I'm just kind of picking on Excel here, but there's a number of different programs that have these same sorts of issues, things like SAS or maybe Minitab or SPSS. A number of different programs have reproducibility issues. But there have been solutions that have been proposed for these solutions that could potentially avoid some of the blunders that we saw in the previous couple slides. And there are several geographers that are pushing for what they call an open geographic information science. And a lot of this revolves around the concept of literate programming, which essentially means making script and code readable, making it easy to produce, but also easy for people to interpret the results and figure out what's going on inside of the code. So literate programming has been one potential solution. And others suggest using a little web framework like Shiny or Flask as a sort of companion resource to a published article, so that those who are reading the article could explore the data on their own and maybe generate their own questions and potentially their own insights. And now it's becoming more common as well that some journals are requiring code and data to be submitted in order for a paper to be considered for publication. So the International Journal of Geographic Information Science is one that's doing this. A number of journals affiliated with Nature and a number of journals in the Public Library of Science are doing this as well. And this solves a lot of the problems, but doesn't quite take care of everything. And at this point, I'd like to make a distinction between reproducibility and replicability, and hence the adjustment to the title of my talk. But reproducibility means verifying previous results using the exact same data and exact same methods of analysis, so not changing anything. And this differs from replicability, which means using a previous analysis but going and using that analysis on a new data set in another context, and in order to sort of extend that analysis and try it in a different situation. So there's a difference between reproducibility and replicability. And what I contend in this talk, and what I've kind of focused my research on over the past couple of years, are these two next points here. So I contend that the technical side of the reproducibility problem has been addressed. It's not totally solved. I think a lot of what needs to happen is probably a cultural shift, but at least the reproducibility problems are being addressed. That said, replicability problems still abound. Being able to extend an analysis to another situation or another context is still a major challenge. And I also contend that most of the conversations about reproducibility and replicability revolve around analysis. And for the record, I think analysis is the most important part of the scientific process. But there are some other parts too that could benefit from enhancements in the replicability realm. And so I posit the question, what about data acquisition? Oftentimes, when we conduct an analysis or we're investigating an analysis that somebody else has done, the data sort of appear out of nowhere. They might be in a Git repo in a folder called data, or from a web resource, or sitting on a hard drive somewhere for a couple of years, and the data just kind of exists there. But what about this process of data acquisition, and what can be done to make it more replicable? So what I propose are two things here. One is better workflows for acquiring secondary data. And this is more of a sort of, I guess we could say, advocacy perspective here, because a lot of this sort of work has already been done. But then in my research, I'm focusing specifically on better tools for acquiring primary data. And I envision these tools that they would be replicable, so they would allow for reuse in other contexts, and then be extensible. They would be flexible so that they could be extended for specific use cases. So I'm going to go back to the list of things that contribute to e-reproducible research and talk about how some of these could be addressed by better procedures for data acquisition. Something like selective reporting or fraud. Again, those are probably like cultural issues within the academy that need to be addressed. But several of these, like the process not being replicated enough in the original lab, methods and code being unavailable, poor experimental design. I think these are things that could be improved upon by better data acquisition measures. And one thing I'm trying to do too with these projects is on this technical expertise point is lower the barrier of entry to make it easier to use tools that are replicable so that others can use them in whatever context they see fit. And so on that sort of first point about better workflows for acquiring secondary data, I'm going to talk about two common procedures that we as geographers often have to do, extracting data from the US Census, and then also retrieving data from like the Wisconsin Department of Natural Resources. And not everybody will have had experience with these, but you can maybe envision how your field might be similar. So within the US Census data portal, there's this nice search tool where you can go in and you can select the geography of interest. And let's just say that we're interested in studying something like income within Eau Claire County. So we can go down here and select, okay, tract is what we want, and we want tracts just within Wisconsin. So we can click here, and then we can scroll down and find Eau Claire County. And then we can designate, okay, we want all census tracts within Eau Claire County. And then we could search for various socio-demographic products that are available through the census. Then once we have the product that we're interested in, we would then need to get the spatial data because this census data portal only gives us the non-spatial data. So then we could go to US Census Tiger files and extract the spatial features, and then we could unzip those and put them inside of a GIS, and then we could take this socio-demographic data and also put it inside of a GIS, and then we could go and join those based upon a common field, and then we might have to go and remove the second row from the socio-demographic data because there are two headers, and sometimes it causes data type problems. So we would have to do all these things, but we would eventually have our data. And all of this, I argue, can be pretty simply automated with a simple script. And the code here is not super important, just kind of the general principle of what's going on here. But R has a package called Tidy Census, which has a function called get ACS for Get American Community Survey Data, where you can simply specify the location that you're interested in our case, Wisconsin, the county, Eau Claire County, and then the geography type, the scale of analysis is the tract. And here I specify an exact variable. And the nice thing about this approach is that there's no ambiguity about what income variable this is. So within any given year of American Community Survey data, there's literally tens of thousands of variables. And so when we look at a map of something like income, it could be per capita income or median family income or a number of different measures. Here, there's no ambiguity about which measure we're talking about, and we can look up the documentation about this variable specifically. And then we can also just simply copy paste this code and use the same code in another context for another geographic area. So this is the county that I graduated high school from, the state of Missouri in Cass County, and then everything else simply remains the same. And I should note here that this geometry equals true flag just tells R to also extract the spatial features. So the person who wrote this package, his name is Kyle Walker at Texas Christian University. He did a lot of that sort of grunt work of extracting the geographies and doing the combining based upon a common field. He's taking care of all this inside of the package, so we don't have to do that on your own. I'm big on the DRY principle, the do not repeat yourself principle. And that's one way that we could make acquiring secondary data easier. So another common data source for geographers is the Wisconsin DNR. And so I have here trout habitat project points. And let's say we were interested in doing some analyses on these points. We could go here to download and find the format that we want, whether it be a spreadsheet or KML or shapefile. And we could download that and then unzip it and then add it to a program to do our analysis. Or quite simply, there's a button for APIs here where we can just hover over the GeoService or GeoJSON And we can take this link and paste it into a simple script where we ingest the data directly and don't have to worry about the sort of roundabout procedures. And again, there's little ambiguity as to which data set we're working with, besides the fact that it's not very nicely named. But we could simply share this with somebody else and they could do the same sort of analysis. And they could, if there were some analysis actually involved in this script, we could just substitute in a different data set for trout habitat points in a different state, for instance. Okay, so with secondary data, it's clear here that the greater onus is on the data providers to serve out their data using application programming interfaces like the US Census does with the US Census API, or provide the data in some sort of easy to digest format. And so this is more of a task for the data providers. And once that has been done, if more data providers would do this, then the research community just would need to adopt this sort of procedure. But I'm going to talk about my tools for acquiring primary data and what I've been working on in order to hopefully make the data acquisition process a bit easier. But before I do this, I'm going to delve into some previous work that's along the lines of the subdiscipline of geography that I'm sort of interested in at the moment, that of spatial cognition, which has to do with how people perceive space and place. And there was a paper published in 2009 on how people perceive the Dust Bowl and how perceptions changed over time. So there was a grad student at Oklahoma State University who went to every county within Oklahoma, all 77, and found 3 people to interview and handed them a paper map and said, where do you think the Dust Bowl was? And so people, were able to draw on the map. And once that was done, if you want to do some analysis on the data, you have to take those individual paper maps, you have to scan them, and then you have to georeference them. So kind of align the image to the correct spatial location. And then for each response, you have to digitize. You have to go in and sort of draw around the person's response in order to convert it to a digital data set. And so this can be done and has been sort of the common procedure, but it's a little bit cumbersome. The same sort of thing has been done historically in the study of vernacular regions. So this was sort of a landmark paper on the vernacular regions of Texas, where Terry Jordan did a similar sort of approach where he mailed out these surveys to people across the state of Texas. And people would annotate on the map and label different regions, and then you can go back in and digitize the responses and then do the analysis. And one question that I'm interested in is how people perceive of the Midwest of the United States, and there are different definitions. This one is from Encyclopedia Britannica, but is also used by the US Census. And there's different methods for studying vernacular or perceptual regions, but the most common way is to hand people a paper map and ask them to annotate it, and then you have to go back and digitize. And this is something that I've done in my classes for a number of years, where I will hand these maps out in class and say, draw a circle around what you consider the Midwest of the United States, and then I'll take the responses back to my office and then find ones that look similar, like you can see these 2 here, and then find ones that look interesting that perhaps exclude certain states. And the X's here represent the student's hometown. And one sort of interesting facet of this is that people have a tendency to place themselves at the center of the region that they feel that they belong to. But all of this takes time and it's tedious. And we would like to do something that is a little bit more immediate so students can see results right away. So I've coined this term, the Map Survey Project, as a sort of toolkit for acquiring spatial data, particularly in regard to spatial cognition and how people perceive space and place. So this has started as an SRU in the summer of 2019, where my research group and I made a series of web applications that would automate this process and allow us to simply collect the data digitally. So this is one where you can simply draw a polygon around the area that you consider the Midwest of the United States, and the respondent can delete the polygon if they want to and draw a new polygon if they weren't satisfied. And this is part of a study that that I've been working on over the past year or so with a guy down at Arkansas Tech University. And so we're interested in comparing responses from students at Eau Claire to those in Arkansas Tech and applying machine learning models to the data in order to try to find breakpoints that effectively separate the responses, and also to get a better understanding of how we can build models to classify people's responses. And how I would like to see this extended is to have a small software package where there would be a set of templates where somebody could simply say, okay, I want the perceptual regions template, and I want to run the app on my server that that corresponds to this template. And so instead of studying the Midwest, maybe somebody is interested in the South instead. So they can change the title a little bit. They could even supply their own custom instructions, which would be populated inside of this little box here. And then they could also alter the center of the map if they felt like that was necessary, or even change the base map. There's a number of different base maps out there. So if somebody wanted like a dark base map or one that just had satellite imagery, something like that could be done instead. And also, as a part of that perceptual region study, we also emailed this survey on location of knowledge of world cities, on where these cities are located. And geography has a reputation of being a discipline that's all about just like locating cities on a map. But I would hope that by using a digital sort of platform, this would allow us to ask deeper questions and allow for richer sorts of richer analyses. And so as a part of that study with my collaborator down at Arkansas Tech University, we were particularly interested in how students perceived the location, or how well they could identify the location of Edmonton, Canada versus Mexico City, specifically to study the effects of proximity. So Eau Claire is about the same distance from Edmonton as Russellville, Arkansas is from Mexico City. So we wanted to study the effect of proximity on locational knowledge of cities outside the United States. And of course, there's a whole slew of issues that go into that. Like the size of the country and the relationships between those two countries. But that was the idea behind this application. And similarly, I envision that this sort of toolkit will allow somebody to simply reference the templates, the locational knowledge template, and they could change the title if they wanted to. And maybe a researcher is interested in not Tokyo, Japan, but maybe in Beijing, instead of Mexico City. It could just substitute in Buenos Aires, Argentina, for instance, and then the colors and the background could be changed as well. And I should note here that this is just pseudocode, like this is currently not working. The apps right now are sort of standalone applications that are quite long and not as modular as this, but I would like to see something like this take place that would be more modular. And so I'll just share one more, and this is one that we haven't actually distributed yet, but on things like residential desirability. So this one says, rate the following regions of Wisconsin based on how desirable they are to live in, assuming that the location of family and friends are not factors. And so the scale here is a Likert scale, from 1 being not desirable and then 7 being highly desirable. And so respondents can go in here and rank the various places. And again, this sort of thing could be modular, so that we could just sub in a different state, change the number of regions from 10 to 12, change the scale instead of 1 to 7, have it be 1 to 5 instead. This random seed here is in reference to the random number generator that's used in k-means clustering. So what's going on here sort of behind the scenes is that these are counties, and then we use k-means clustering in order to cluster the counties into regions, and different random seeds will produce different results. And of course, this could be done manually as well, to assign various counties to a particular region. And this would have applications for things like tourism. And if this was combined with open-ended questions about why you rank certain places that way, could help regions of Wisconsin understand how they're perceived, and how they can maybe capitalize on their perception for the sake of tourism. So a couple of advantages of this approach is that these web applications can operate as a direct interface to the user. So there's no need for going back and manually digitizing afterwards. This also allows for what I call on-the-fly analysis, which could be incorporated into things like machine learning pipelines. So in the study of perceptual regions, for instance, this has been something that we've been collecting data on continually. And so on my computer, as new responses come in, I simply ingest those responses and have a set of automated scripts that produce some visualizations and produce some maps. And even that could be set up in a web framework that would display the results immediately. And we're not quite there to that point yet, but it could be done. And hopefully the code could be modified and then just applied in other contexts, and other people could use it as well. This summer, I'm planning on working on a project studying how people perceive cycling safety in Eau Claire. So pending how things go with COVID over the next few months, what I would like to do is have myself and a couple of students walk around Eau Claire with some tablet computers and just give somebody a short survey and say, okay, mark on this map where you think there are places that are unsafe for cycling. And they'll just be able to, just kind of annotate with their finger and mark on different places. And then ideally, what I would like to do is build models that help explain how perceptions relate to the built environment, things like street width, traffic volume, the presence or absence of bike lanes, also things like intersections. And then also too, to combine this sort of spatial survey with demographic information to understand how perceptions differ based upon characteristics like race and gender. Cycling is notoriously pretty much a white male activity in the United States. So understanding these perceptual differences could potentially make cycling more inclusive if we understand how people perceive their environment a little bit better. And so a few challenges of doing this, and with reproducibility and replicability in general, is that creating these tools is time consuming, and oftentimes the alternative toolkits are a bit easier to use, at least at first. And also within the academy, at least, creating tools is more seen as a sort of like industry exercise and does not have the same amount of prestige as empirical research. And at a lot of institutions, I don't feel like it's necessarily this way at Eau Claire, but at a lot of institutions, creating tools does not come with the same rewards as publishing papers, simply. But also figuring out how to integrate quantitative with qualitative approaches using these methods. So historically, spatial cognition and vernacular regions has been something that has been studied mostly by cultural historical geographers who focus on qualitative methods, and I'm trying to approach this in a quantitative way. And I think there are some dangers of trying to quantify everything, of course. So figuring that integration out will be a challenge. So I did create this presentation using a plain text format that was rendered into an HTML5 presentation. I'm happy to drop this in the chat if you're interested to see the source code behind how I produced the presentation in the spirit of replicability, and maybe you could adapt this for your own use case if you found it useful. And so with that, I'd be happy to take comments and questions. So thank you all so much for being here.
Thank you, Matt. Questions for him? Again, you can unmute yourself and ask directly, or if you prefer, drop it in the chat box.
So Matt, hi, this is Doug. Just a quick question. This issue of replicability, I mean, it also seems it's clearly tied to transparency, and such as the code used and the like. Yeah, I agree. It seems like a major issue. How widely spread is the concern? It's heartening to me that you've identified this and others, but is this something that is, I saw you have a list of references at the end. Is this a big movement for people to address and come up with better ways? I know you cited those journals, that are trying to move towards this, but is it gained major traction?
I think it's starting to. The International Journal of Geographic Information Science just published a special issue dedicated to reproducibility and replicability. And they've been doing a lot with this sort of stuff, but I know Nature has made a big push for it. I don't know if Science, the journal Science, has made as big of a push, but yeah, it would seem like to me it's becoming a bigger issue that's getting more attention. I think it has some significant weight behind it.
Well, that's great. It just seems one issue that some researchers could have. It's adding to is like, oh, it's more I have to document, more I have to do, which is what they should do. But in a place, by a place, I mean kind of our culture as academia and pressure to publish, especially at R1s, publish a lot. That adds to the workload. And I can see that kind of coming in to some sort of conflict. Do you have any sense about that?
Oh, for sure. Yeah, yeah. And I think that's one of the main challenges is that it just takes time. It takes time to do this. And also too, I think some people don't necessarily want to share their code because they might try to monetize it. So you kind of use a journal article as an advertisement, but then keep the code proprietary so that they can profit off of it. Obviously, like you don't want to be sharing your code in that sort of situation. So yeah, I think the time issue is huge. Yeah, but plenty of other issues as well. I know in some disciplines, like reproducibility is challenging just because of the nature of how studies are conducted. If there are any chemists here, maybe chemists can chime in. But if you're like physically mixing chemicals and pouring one thing into another, you can document that well. But yeah, I would think that would be something that would be especially hard to reproduce because you can't just do it all in code.
Matt, this is Catherine. So
Mhm.
I'm actually very interested in your map survey project, the tool. I wonder uh, how widely have you disseminated or shared that tool? I know perhaps you're still working on it. Well, we never stop working on stuff, do we? Because it looks like certainly a very interesting tool, and I can actually see applications beyond research, even in like K through 12. So I'm just curious.
Sure. Yeah. So I'll kind of tackle the second part of that first. What I would love to see if this project goes successfully over the summer is to create a modular platform that people in La Crosse or Madison could simply, distribute the same sort of study where they just go on the ground and, change a couple of lines of the code and they could study cycling and pedestrian safety in these other places really easily. And that could help inform like urban planning decisions and things. So on the first part of the question, how I've disseminated this, not widely, because the code right now is basically all just duct taped together, and there are large portions of it that I'm surprised work. So there's a lot of work that needs to be done in terms of making this something that others could use. And part of that is because I'm trying to publish papers with the code rather than just like work on the code itself.
Yeah, thank you.
Yeah.
And obviously, as you kind of mentioned, developing tools sometimes is perhaps an undervalued endeavor, but I would argue that, at least personally, that it shouldn't be that way because we are trying to make resources available for the community, for the public good.
Sure. Yeah, and there are some journals out there that are trying to sort of fill this gap. I guess there's a journal called Software X that specifically takes journal articles that feature software publications. There's the Journal of Statistical Software, which does something similar. Journal of Open Source Software. So some journals are trying to do this, where like academics can get credit for publishing a paper, but what they're really trying to, produce is the code or a toolkit or something. But even that takes time. Like as I'm building a tool, I would probably rather just, create the tool and publish the code and the documentation and not have to like write a research article to go along with it, I guess. So.
Yeah, Matt Harry here. One of the things that I've heard about is that within NSF, there is ways to submit and document any research that anyone has done, be it a profile in my case, be it a map, be it software, and get a DOI number.
Oh, okay.
So those DOI numbers now are, the currency that a lot of people are looking for. And so from my understanding, that is up and running now. And that anything you do or anyone does can be submitted for a DOI number. And that, now it's published as a DOI number. So that may be one idea. I have not done that yet. I'm looking at doing that. But as you say, it still takes time to package it and then submit it to get that DOI number.
Sure. Yeah, I was not aware of that. So that's cool to hear. Yeah, one of my sort of fears of like publishing the software package is that if people start using it, then somebody has to maintain it. And the logical person to maintain it would probably be me if I wrote it, unless I could convince students to do it and train them well enough so that they could that they could sufficiently take care of it and identify bugs and things. But yeah, that's a cool development.
Any other questions for Matt? Well, it looks like perhaps at least Doug Faulkner has to go teach, so he dropped a
Okay.
a comment in the chat box. So unless folks have additional questions, I'd like to thank Matt again for sharing his work here, and good luck, of course, with the ongoing elements of the project, and hopefully you can make a lot of progress this summer.
Thank you. Yeah, and thank you all so much for coming.
Yeah, thanks everybody.